Hi, everybody. In this video, we're going to be reviewing topics 3.3 all the way through 3.6. And we're dealing with numerical expressions and then algebraic expressions. When you're working with numerical expressions, as the name would suggest, we're dealing with just numbers, okay? No variables involved in numerical expressions. So here I have 6 plus 4 times 5 minus 16 divided by 2. You might be thinking, well, that looks familiar. Don't we just follow our order of operations? And yes, that's exactly what you need to do to solve this. So I have adding and multiplying and subtracting and dividing. Order of operations says multiply and divide before you add and subtract. And you multiply and divide in the order they appear from left to right. So we're going to do 4 times 5. We also will be taking 16 and dividing it by 2. 4 times 5 is 20. 16 divided by 2 is 8. So now what I have is 6 plus 20 minus 8. All that's left now is adding and subtracting. And as you know, we do those in the order they appear from left to right. 6 plus 20, that's 26. And finally, 26 minus 8 gives us a final value of 18. So we are evaluating these expressions or finding their value. When you show all of your work, you're going to see they make this nice upside down triangular shape because each time each line is a little bit more simplified than the one before it. All right, let's look at another example here. Now in this example, I have some parentheses here. We have multiplying, subtracting, dividing, multiplying. But whenever we see parentheses, remember your order of operations. Pemdas, right? P is for parentheses, E is exponents, M and D is multiplying and dividing, A and S is adding and subtracting. So we do them in that order. PEMDAS. Please excuse my dear Aunt Sally. All right, so the first thing I want to do here are the parentheses, the grouping symbols. 8 minus 2 is 6. And over here, what's 2 times 4.5? Well, that's equal to 9. Okay, so what I have then is 3 times 6 divided by 9. Now some of you might have needed to show work to find 4.5 times 2. Some of you are thinking, no, I was fine. I was able to do that just mentally. 2 times 5 is 10, carry the 1. 2 times 4 is 8, plus 1 is 9. And then we have the decimal point in one space. So 9.0, or just 9, is what we get here. All right, now I have multiplying and dividing, and I do those in the order they appear from left to right. 3 times 6, that's 18. And then 18 divided by 9 equals 2. Again, you see that very satisfying upside down triangular shape as we work our way down, defining the answer in simplest terms. We evaluated it all the way down to 2. All right, so that's how you handle numerical expressions. It's just order of operations. Algebraic expressions, now we're moving into sections 4 and 5 of topic 3. Algebraic expressions have something called variables in them, like 3a minus 2b plus 5, 2x plus 4y minus 3z plus 8. These are representing values that can change. We can put lots of numbers in place of those variables, and we'll get different results depending what we put in there. But the first thing I want to discuss is, what are terms? Terms are parts of these expressions, and they are separated by plus signs and minus signs. So here I have 3a minus 2b plus 6. I have 1, 2, 3 terms in this expression. Okay? They are separated by the minus and the plus signs here. Over in this one, how many terms do I have? Well, I have 4 terms here. And you can see we have this is a term, 2x, 4y is a term, 3z is a term, 8 is a term. They're separated by the plus signs and the minus signs. Okay, so we do need to understand what terms are and how many terms there are in an expression. Okay, so anyway, here I have 6w divided by x plus 9. And I want to evaluate this expression for t equals 8. Well, there are no t's here. W equals 1/2. X equals 3. So what I'm going to do is substitute these numbers in place of these variables. So instead of 6w, which means 6 times w, remember if there's no time sign here um, between a number and a variable, that means we're multiplying them together. So I have 6 times w. That would be 6 times 1/2. And again, I like to show multiplication using parentheses, 6 times 1/2. Divided by x, x is 3, and then plus 9 at the end. Okay, what is 6 times 1/2? Well, that's the same thing as 1/2 times 6. Times and of mean the same thing. So really I'm finding half of 6, which is 3. 3 divided by 3 plus 9. Next I do my dividing. 3 divided by 3 is 1. And then 1 plus 9, we get our answer here of 10. We find its value, it has a value of 10. Easy, right? Let's try another one. 5x minus 2w plus t squared. Now again, 5x really means 5 times x. 2w really means 2 times w. So let's rewrite this and fill in some numbers here for these variables. X is 3, so instead of 5 times x, I have 5 times 3. Really what I'm doing right now is I'm just rewriting the expression as a numerical expression. I'm putting numbers in. Minus 2 times w. W is 1/2. Aren't you glad that 2 is even because we're going to have to find half of it? It's kind of nice. Plus, and then t squared. T is 8. So I have 8 squared. All right, now, if you follow your order of operations, next thing we would do would be the exponents. But you see how 8 squared is a separate term from the 2 times 1/2 or the 5 times 3. They're separated by this minus sign and this plus sign here. What's nice about that is I can just solve each of the terms, find each of the values of each of the terms, and then do my subtracting and adding. So in this first term, 5 times 3 is 15. Minus, in the second term, 2 times 1/2 is just 1/2 of 2 is 1. Plus, and then in my third term, I have 8 squared, which is 8 times 8, which is 64. Then I can add and subtract from left to right in the order they appear. 15 minus 1 is 14. And 14 plus 64 is 78. And I have fully evaluated that expression and found its value to be 78 when we put these values in for t, w, and x. All right? Now, what do we do? Here we have topic 3, section 6. We're generating equivalent expressions. What do we do when we want to write an expression equivalent to, for example, 4 times the quantity 2a minus 8? Well, this is where we use what is called the distributive property, okay? And this is where we take the number out in front of these parentheses, out in front of this quantity, and we distribute it through like a mailman distributing the mail in the different mailboxes on his route. So we have to multiply 4 times both of these terms inside of this quantity. So we take 4 times 2a. Remember, this is what I like to call bombing the fort, like we're bombing a fort here in a battle. So I have 4 times 2a minus, and then I do that to the next term as well. 4 times 8. So we're distributing the 4 through that quantity and multiplying it by both terms inside of the quantity. So 4 times 2a is 8a. I don't know why it doesn't write sometimes. Minus, and then 4 times 8, that's 32. So 8a minus 32 is an equivalent expression to this one up here. Now notice I cannot take 8 minus 32 because I don't have an 8 here. You might be thinking, yeah, you do. It's right there, 8. No, that's really 8 times a, and I don't know what a is. But I do know I have to multiply these together before I can subtract 32. Okay, so I have to leave it like this, 8a minus 32. I cannot go any farther until I am given a value for a that I can substitute in there. Okay, so let's move to another example here. For a plus 2b, can I write an expression equivalent to that? Well, this one's different because I don't have a number that's being multiplied by some quantity like we had over here. Instead, I just have, it's almost like I have a final answer like this 8a minus 32, and now I want to work backward. I'm just going to try to get rid of that there. And I want to work backward to get to the starting point where you have a number times some quantity. So what I'm going to do is, instead of multiplying it through with the distributive property, I'm going to figure out if there's something that I can divide into both of these terms. Do they share a common factor? That whole greatest common factor discussion from the other video, that's what I want here. What's the greatest common factor of 4 and of 2? And it's 2. I can divide these both by 2. And when you divide them by 2, 4 divided by 2 is 2. All right. So what I have here is I'm dividing them both by 2. So I have 2 times, and then 4 divided by 2 is 2. So I have 2a here plus 2 divided by 2 is 1. So I have 1b here. So I have 2 times the quantity, 2a plus 1b. If you were to bomb the fort here, 2 times 2a is 4a. 2 times 1b is 2b. So this right here has the same value as 4a plus 2b. It's an equivalent expression. Now I could also just simply write 2 times the quantity, 2a plus b, and not even show the 1 in front of that b, because how many b's do I have there? 1, just like you see there, and both ways would be fine. All right, we're going to do one more here. 3m minus 6n plus 3. How many terms are there in this expression? Do you see 3 of them? I see 3 of them. Here's a term. Here's another term. Here's a third term. And what I'm going to do is figure out if there's a common factor that I could divide into all 3 of these. And we have 3, 6, and 3 there. All of those are divisible by 3. So why don't I just go ahead and put 3 here? And then in parentheses, figure out what I would have to take times 3 to get 3m. 3 times what is 6n? 3 times what is 3? Another way of looking at it is I'm dividing each of these by 3. So, 3m divided by 3 is 1m. I could show the 1 in front of that. Maybe I should, huh? 1m. Minus 6n divided by 3 is 2n. Plus, and then 3 divided by 3 is 1. Okay, so there we go. I have written an equivalent expression. And again, I don't need to show the 1 in front of that. We could just write 3 times the quantity m minus 2n plus 1. And that would be another way. I like this second way of writing it a little bit better. It's equivalent to that original expression. Okay, so there you go. That's a review of 3.3 through 3.6. Good luck on the test tomorrow. If you study well, do your review assignment today, you should be well prepared for the test tomorrow, and I hope you do really well. Have a nice day.